Okay, these notes are over the remainder and factor theorems. So if f of x is 2x to the fourth minus 5x squared plus 8x minus 7, and we want to find f of 6, we can actually use synthetic substitution or synthetic division to find f of 6. So it's the same idea that we're dividing the polynomial by x minus 6. So you set up your synthetic division. So along the top we have 2, 0, negative 5, 8, and negative 7. And we're dividing it by positive 6. So we always bring our first term straight down. And then we multiply 2 times 6 is 12. We add together the next column. So 0 plus 12 is 12. Now we multiply 6 times 12 is 72. And we can add going down, negative 5 plus 72 is 67. Then we multiply 6 times 67 is 402. We add going down, 8 plus 402 is 410. And we multiply 6 times 410 is 2,460. And then we'll add negative 7 plus 2,460 to get 2,453. Now, our remainder is 2,453, which means, because of synthetic substitution, f of 6 is 2,453. So whatever you're dividing by, the remainder is actually what f of whatever that function is. So instead of having to plug in positive 6 into each x and solving, you can use synthetic division and use the remainder to solve. So the next example, I have 2x cubed minus 3x squared plus 7, and I want to find f of 3. I could plug in 3 for x and solve, or I could do synthetic division. So I have 2, negative 3. I'm missing an x, so I'm going to have 0 and then 7. And I'm dividing it by positive 3. I'm going to bring my first term down and then multiply. 3 times 2 is 6. Now I'll add negative 3 plus 6 is 3. I'm going to multiply 3 times 3 is 9. And then I can add 0 plus 9 is 9. Now I can multiply 3 times 9 is 27. And then add going down, 7 plus 27 is 34. So f of 3 is actually 34. We can also determine whether x minus 3 is a factor of x cubed plus 4x squared minus 15x minus 18. And we actually did this earlier this week. So the way that you can tell whether it's a factor or not is if your remainder is 0. So here we divided x cubed plus 4x squared minus 15x minus 18 by 3 using synthetic division. So we brought the 1 down. Went through this whole process, multiplying. 3 times 1 is 3. Then we add 4 plus 3 is 7. Multiply 3 times 7 is 21. Add negative 15 plus 21 is 6. Multiply 3 times 6 is 18. Add negative 18 plus 18 is 0. So our remainder is 0, which means x minus 3 is a factor. From here, though, we can actually go further and keep factoring this polynomial. So the 1, 7, and the 6 are representing 1x squared plus 7x plus 6.
Students, please remember to sign up for tutoring.
So we can actually factor this quadratic like normal. So I need factors of positive 6 that add up to positive 7, which are 6 and 1, which means this factors to be x plus 6, x plus 1. So I factored this polynomial completely. So x cubed plus 4x squared minus 15x minus 18 factors down to be x minus 3, x plus 6, x plus 1. Which this is just showing the exact same thing that I just got done doing. So here I'm determining whether x plus 2 is a factor of x cubed plus 8x squared plus 17x plus 10. So to determine that, I'm going to use synthetic division. So upside down, I've got 1, 8, 17, and 10. And I'm dividing it by what x equaled. So x plus 2 equals 0, so x equals negative 2. I'll bring my first term straight down, and then multiply negative 2 times 1 is negative 2. Then I'm going to add 8 plus negative 2 is 6. Then we'll multiply negative 2 times 6 is negative 12. And then we'll add 17 plus negative 12 is 5. We'll multiply negative 2 times 5 is negative 10. And then we add 10 plus negative 10 is 0. So I have a remainder of 0, which is what I want. So x plus 2 is a factor. So I can get rid of answer choice D. The remaining factors are going to come from x squared plus 6x plus 5. So I need factors of positive 5 that add up to 6. So that would be 5 and 1. So this factor is to be x plus 5, x plus 1. So we get answer choice A. And that is it. Now, when you're listing all of your factors, you do need to list the x plus 2 as well to list all of them. But that is it for the remainder and factor theorems.